Hello everyone, so in this video I'm going to show you how with a little bit of magic, pun is actually intended, that you can basically run your pandas code on a GPU and get sometimes even 1,000 plus times speed up. So by a little bit of magic, what I mean is that you can literally just write this magic, Jupyter magic thing, this percent load x CudF.pandas, and voila, now your pandas code will try to use a GPU whenever possible. So in this library, this thing uses under the hood a library from Nvidia's Rapids.ai called CudF. So CudF, loosely speaking, is basically like pandas on a GPU. So it's part of Nvidia's Rapids.ai. Rapids.ai basically is accelerating data science tasks to GPUs. So for example, you'll have QML is like scikit-learn on a GPU. My last video spoke about that. You have QPy as NumPy on a GPU. And here in this video, CudF is basically pandas on a GPU. So this is what we're going to be talking about. If you enjoy my videos and want to see a lot similar content, please like, subscribe, and share. It means a ton. Thank you so much. So let's get started. Okay, so CudF basically is basically a Python library for GPU accelerated data manipulation. It basically allows you to do super fast loading, joining, aggregating, filtering, and manipulation of tabular data, and it uses a GPU. That's CudF. It's different from CudF.pandas. CudF.pandas is that extension thing I was speaking about earlier, which basically looks like pandas, feels like pandas, does everything like pandas, but tries to use CudF instead of pandas whenever possible. So most of the things I tried actually work out of the box with the CudF magic extension. Sometimes they work slower because they're not GPU compatible, but then CudF.pandas falls back to the CPU and it'll still work. In a few instances, I got like errors, rare, but it's very, very small amount. So I was actually very impressed because it's a lot better than it was like a few years ago. And they note that they have like 93% plus coverage on pandas unit tests and that sort of thing. I want to show you kind of a schematic on how it works for a second. Is basically you have your code and your code calls a pandas function, and the pandas function gets translated to the CudF function or method, and it gets a result. That's if there is a CudF function or method. If they don't have that function or method, then not all is lost. It copies it to the CPU, uses good old pandas, and then copies back to the GPU and gives you the result. So worst case scenario, it just copies from GPU to CPU, runs good old pandas, and throws it back to the GPU. So that's why most of the things work. Just some things might be slower if they're not supported yet. Okay. And of course, you need a GPU. So if I go to runtime, if I'm using Google Colab, I do runtime, change runtime type, I pick a GPU. You probably need, the free version gives you GPUs for a little bit. So choose a GPU, and once you choose the GPU, we can get started. So to get started, first you need to, I recommend, even though it does come pre-installed with Google Colab, I recommend you install like the latest version because sometimes like some operations are not always working. So you can do this Nvidia SMI thing. This Nvidia SMI thing basically gives you info on your GPU, like temperature, memory, that sort of thing. But for our purposes, the important thing is it gives you like a CUDA version, so 12.2 in our case. So then if you go to the link here, you get the install link. We can install the right CUDA version. So let's use pip, and let's say CUDA 12. Let's choose specific packages. We're going to only want CudF for this one, so copy command. So now to install, I will do this thing. So I'll do pip install. And now look at this. So once this installs, which actually took a second, didn't seem like it did. Oh, because I ran this earlier. Sorry. So, okay, this is the magic. All you have to do is this thing. And magically, it runs on your operations run on a GPU. okay, which is crazy. Just show you can do like basically you can make yourself feel at home, make yourself feel at pandas, right? So you do import pandas, oops, sorry, as PD, and then you can create a data frame. You can do df equals PD dot data frame. It's just random data frame df, right? And you can do df equals, let's say, PD dot series. You can also make a series version of it. You can do whatever you want. It's normal pandas. Like missing values behave the same. The only thing is dates. Sometimes not everything is like implemented, especially the depreciated things, which you probably should not use anyway. But anyways, it's kind of cool. You could just use pandas as is, and it's accelerating it whenever possible. How do you know you have CudF working? So you can actually print PD. Oops, sorry, print PDF. Print PD. I print too many PDFs, I guess. So you see you have module is pandas, module accelerator, fast is CudF, slow is pandas. So it's amazing. So now let me just show you just random examples using pandas as is, show you how it looks the same. Then I'm going to show you how to profile your code, because you're saying, am I even getting any speed up? So profiling is what happens. It shows you like what part of your code is running on GPU, what is running on CPU, that sort of thing. So I'll show you profiling. And then I'm going to actually do like a benchmark comparison speed test between GPU and CPU operations to show you that you really do get some serious speed up in some cases. So let's get started. So let's mount the Google Drive, and I think I already did this earlier, so it'll give me an error. So import OS, google.collab, import drive, and I'll see if I'm able to share this file with you guys if you want to use this file. So I'll load the data frame, PD equals read.csv. It looks like normal pandas, right? So my drive, and I called it a df Nvidia all.csv. And look, even these things look the same. I can do index call equals 0, parse dates equals true. This only works with the latest version, the parse dates equals true, but anyways. Now you can do df.head, and look, it's like normal pandas looking thing, right? And you can do like, since we're doing finance related things, we can do moving averages, you can do that. Rolling 14, close, dot mean. I'm just showing you random examples, honestly. Okay, so this is our data set. So I can have a rolling 14 period mean, right? Okay. Anything you want, you can do pretty much. So later I'll show you below, like, I'm just showing you that I'm not getting an error running this, but below you'll see that it's not implemented on GPU. So it's not you're actually not getting speed ups, you're actually getting speed downs. But let's say a rolling 14 period mean, exponential weighted moving average, I can do close.mean 14 period. I can do also close dot standard deviation. STD, sorry. Oh, sorry, this is rolling STD. Okay, whatever, we can run that. But you can also do like exponentially weighted moving average STD. You can do everything you want. You can do group bys, df.groupby. Let's see, pandas grouper 1 day mean. Anything you want, you can pretty much do. df.between time, 10, 11. Because my data set is basically has the index, has a date time, has open, high, low, close, volume, average. So let's say I want market hours. I can do between time 9:30 to let's say 5-minute bars, so 15:55.55. So you can do whatever you want. It's kind of cool. So I'll show you a few instances where it doesn't necessarily work. So sometimes they'll have something like, let's say Yahoo Finance. So I do from Y Finance, import YF. And soon I'll show you like what part of these operations are in GPU versus CPU and that sort of thing. So like for Yahoo Finance, I'll do import Y Finance as YF, and then I'll do like I should have YF dot download. I forgot. When you don't have a screen, I don't have a second screen, so it's kind of I'm doing this like by heart. But whatever, let's copy this thing. So like you can have like your history, but you'll see you're gonna get an error. So like it says cannot slice indexing on datetime. So what I was saying is the biggest time I found errors were things like data types like timestamp and basically category data types. But most things work as is. Let's say you want to use Pandas TA, which is the technical analysis library. You can do pip install Pandas TA. Actually, you usually get an error. You get this weird error. So you can import this weird thing, import locale, and now it'll work. So I'll put this code up so you can see like this like how to fix this error. So look, now I have Pandas TA. I already had it because I did this before. So it's amazing. So now you can actually use Pandas TA. You can literally do, so let's say RSI, so from Pandas TA import RSI, you can do RSI df.close, and look, it works. It's amazing. It actually works. RSI is relative strike index for the non-Python people watching this video. So I would say like even accessors actually work, which is crazy. So they have an accessor where you can do df.ta.strategy, which lets you do like millions of indicators at once. So maybe I'll do all, and then I'll just do to avoid having, let's just run as is. I'm gonna get a lot of problems, but this is trying to do multiprocessing, so it's not going to work exactly as expected. So see, I have all these errors here. So let's actually make it on one core for a second, so because these errors are beside the point. But anyways, not everything works out of the box. Most things work. So I'll do equals 0. This makes it non-multi-threading from my experience. See, but you get an error. See, I told you the two things that give you errors are some of the date stuff and the category stuff. But otherwise, I tried so many things worked, which is pretty impressive. But like you're saying, okay, wow, you showed me all this stuff. How do I know like if I'm even using the GPU or not, or am I just using the CPU? So CudF gives you like profiling tools. So there's a function profiler and a line profiler. So with this other magic thing, you can do this %. Where's my % key? So funny. I couldn't find my % key because my keyboard was dirty. So I can do qdf.profile. This profiles. And let's say I want to profile this. This is the 14-period moving average. So sometimes you get an error the first time you run this. But you see, like, okay, this gives you, it shows you, like, how many times you're calling the GPU and the CPU. So basically 5 GPU calls for, like, 0.092 seconds and 2 CPU calls for 0.244 seconds. So let's look at what's on the GPU and what's the CPU. Rolling is good. It's on the GPU. A lot of things are on GPU. You'll notice that rep HTML or rep latex, which are basically just display things, they're nothing like serious, are on the CPU, so that's okay. And here it tells you like, okay, we didn't implement these yet. If you want to implement it, you can write a GitHub thing. Anyways, okay, so this is one example. This is like a rolling mean. You can have other things, like you can have basically, let's say the max price, the all-time high, is like this, right? So let's see what it uses. Okay, so you see here, 2 GPU calls, 0 CPU calls, which is cool. Yeah, so total time of life is nothing. So this is on the GPU basically. So I don't know. We can do anything you want. We can do. Let me show you one that's bad. So exponential weighted mean, standard deviation. with span is 14. Let's write everything. So now this is an example of something that's bad, because it's not implemented yet and it falls back to the CPU. So it's bad. So basically here you see 4 CPU function calls, 2.645 seconds, 3 GPU ones, and you see, okay, the rep HTML, rep latex, those are okay because those are just like representing things. But if you see the EWM, the exponentially weighted mean, that is covered. But then when you see the moving window STD, you'll see it goes on the CPU and not GPU. So you'll see here below the things that are not there. So the exponentially weighted moving standard deviation is something that you really should implement. But most of the stuff it actually has, they said they have the exponentially weighted mean, but for some reason I see that it's on the CPU. But anyways, this is kind of showing you like what's on the CPU, what's on the GPU, that sort of thing. Later I'm gonna do some speed ups, and you'll see some things that are really like a speed improvement. But here we kind of got the same thing, like same CPU and GPU call ratio. You got like exponentially weighted mean is on the CPU, so it's not necessarily a thing that's covered. But anyways, there's so many things you could do, like maybe a string thing, like we could do like I don't know. Anyways, a lot of things are covered on the GPU. Let's see if I had an example for a second. I really miss having a second screen. I didn't show any. Oh, I did the RSI example. Okay, so let's do the RSI. So RSI is like the function written. So this RSI thing, it does not support explicitly CudF, but when you still run the Pandas accelerated, you'll see that the RSI amazingly uses GPU a lot relatively. It's pretty cool actually. So I can do df close RSI, and look at how much it's going to use the GPU. It's pretty impressive. And I think that was my last example. So you see, look at this. It has 19 GPU calls, 6 CPU calls. But let's see what it's using on the CPU. So it's not. It's similar to last time. The exponentially weighted moving average is kind of a bad guy here. It's not yet implemented on the GPU. But otherwise, it seems to be okay. Did I do any other examples? No. Okay. So now I want to show you guys another thing. So there's a thing called. So this is a function profiler. And there's also a thing called the line profiler. So the line profiler, as I wrote here, where did I write it? Oh, by the way, pd.concat works very well with this. Okay, so the line profiler is this command here. So let me copy that. So this basically, if you have like many lines of codes, it'll tell you one at a time how each is doing. So let's say I do something like this. I do like df equals df dot rolling 14 close dot mean df dot max, and now look what it does. It'll give you line by line what it's doing. So it'll give you the GPU time, the CPU time. I don't know why it's not showing CPU times. It usually does. It's weird. Maybe it's because this was trivial. Maybe it's there's trivial stuff. Let's do a non-trivial example. So like in my other videos, of course, I show you like a ML process, how like you can get dollar bars, which is instead of time bars. Time bars, of course, are like, let's say daily bars, you have the open, high, low, close volume of every day, or like 5-minute bars is every 5 minutes. Dollar bars is instead of 5 minutes, it'll be some dollar amount. So I'm going to show you a process where like I get dollar bars, get like daily volatility, to get price targets, compute labels of whether you'll be one standard deviation above or below hitting first, some sampling of the data, that sort of thing. Just let's not get into details. Let me just show you if I have this. I pretty much didn't change anything in these scripts, and I ran this with the accelerator, the Pandas CudF accelerator. and it actually worked. It didn't work so efficiently, but it worked. So the next task is to try to make it faster, but like if I run the line profiler, look what I get. You'll see what I get. And once this is done, by the way, I want to actually do a straight up like QDF versus Pandas comparison to show you guys like there's some serious speed ups, especially things like I think joins are very, very huge speed ups. Things like things I notice are like user defined functions, stuff like that. Oh. Oh, see, okay, so you see, like, this is this gives you like a GPU time, CPU time for each of the five, 6, 7 lines. It gives you how much each was used, and that sort of thing. So then you can dig in and try to optimize it to use GPUs whenever possible. Okay, so now let's just the accelerator was nice and everything and really cool. But let's just show a straight up QDF versus Pandas comparison. So let me restart the session. The reason you have to restart it is because otherwise, like the Pandas accelerator messes up with the Pandas you want to compare it to. So anyways, so let's first load the data frame that we had last time, which is the exact same thing basically. Do df.head. I don't need to remount the drive because I remounted it before. But okay, I'll import Pandas. Oh, I'm so stupid. I want to show you QDF. Import QDF. And then I can do df equals QDF. That reads CSV. It also looks like Pandas, by the way. It looks pretty close to Pandas. It's pretty much Pandas. Parse dates, expected list. There's some minor things like parse dates. It doesn't work with the latest version, so you can do like write the date itself here. Index call is 0, or you could write date, and you see you get that. So you can convert. So if you look at the type of df, you can do type df, and you see that it's QDF data frame, qdf.core.dataframe.dataframe, right? So you can convert it to Pandas data frame. You can do df pandas equals df dot to pandas, and then if I type this, you'll see I get the type here is a Pandas data frame. So that's the way to convert. You can also convert the other way. Let's say you have a Pandas data frame and you want a QDF data frame. So you can do QDF dot from pandas, df pandas, and you can do df, and you'll see df pandas you saw was Pandas data frame, but now type df is magically a QDF data frame again. So we're back where we started. So let me just show you guys like some random things, like let's say a percent change, for example, right? And everything I'm doing, everything I'm doing, like, don't use it to trade. Just use it to understand the performance, because I'm doing things wrong. So percent change, right? And let's just time everything for the hell of it. Like, okay, let's do a percent change. So I'll time it. Obviously, this is predicting a value you already know, so this is meaningless. But anyways, let's forget the, you know what? Should we make it, okay, let's do this. Fine. I'll write label percent change. I'll make it a little bit more this. So I'm computing the percent change, and then I'm shifting backwards. So now, but let's just compare the time for now. Okay, so now I'm going to do first the QDF version with df, and then I have the Pandas version with df pandas. And let's compare the time. This is just a small operation, doesn't mean much, but even this gives you a little bit of a speed up. So let's run this, and the first time it runs it is actually even not fair, because it sometimes it does the just-in-time compilation, so it's even faster the second time you run it. But as you see, even now it's 6 times faster. It seems like this is 40 milliseconds to 80, about 7 times faster. On with QDF than non-QDF. You run it the second time, you see it's even faster, because the first time it compiles it right before it runs it. Okay, so this for small data frames you can actually get the other thing wins, because the compilation might take longer. Okay, sorting is something that, by the way, our data looks like this, just in case you guys are wondering. So just the last thing is the missing value, and you have a percent change. Anyways, uh, just so you know, by the way, is like all these things still work. Uh, like let me just show you guys just for a second. Is like, let's say this is CuPy, but I can still do isNA.sum. I can do this stuff. I can, you have one missing value, just the last point. So like everything works pretty much the same as normal pandas. You know, I can do everything that's not NA, right? Um, for example, I can do whatever I want. Oops, what did I mess up on? I don't know. I might have messed up somewhere, but uh, yeah. See, so basically, what's cool is it's pretty much like pandas. It supports pretty much everything. So sorting is something that's actually it's very strong with. So like, if I do time and I do df.sort values label percent change change, and I do ascending equals false, and I time this. Remember, the first time it takes a little bit longer. It's wall time is 153 milliseconds, right? But then let's do the pandas version. If I do pandas, and I do, and let's see how long it takes. So pandas takes, as you see, 2.48 seconds. That's 20 times faster, right? Which is, and if you run this a second time, this is even faster, right? So look, this is 95 milliseconds. So let's say this is 100 milliseconds for sake of comparison. So 10 times of this is a second, and then this is 2.5. So this is like at least 25 times faster, which is pretty cool. And okay, filtering is another thing that basically there's a huge speed up sometimes. So like you can filter on things. I guess here we might not notice the speed up as much, but there is definitely a speed up. I'll show you guys in a second. So remember, the first time you run the CudF, there's the just-in-time compilation, so that's why it takes a little bit longer. But when it has to fall back to regular pandas, oh sorry, we're just talking about normal CudF right now. Okay, but before when we talked about the pandas with the accelerator mode, if it has to fall back to normal pandas, then it takes a little bit longer than the regular pandas. But anyways, let's do this comparison. I'll do the pandas and pandas. So I'll run this, and then I'll run this thing twice above. So you see, it's 4 times faster, but when you run it a second time, it's still about 4 times faster. Okay, windowing operations. So you could do df dot rolling 14 close dot mean. Let's do time it df pandas. So you see that here there's going to be a big difference also, I think. But you're going to have things that are not supported, and you'll see it's worse. Like here, let's say I do df dot rolling 14 dot exponential exponential weighted moving average 14 close dot mean. It's not supported. It's not subscriptable. It doesn't work basically. Anyways, I don't want to spend too much time on it. I know this one doesn't work. It's weird. You know what? This will prove me. Okay, but you see, like this regular windowing thing is actually it's nice. It's faster. It's not that much faster as I thought, but like oh, because it's running it a few times. Oh, I did time in an accident. So it's okay. 7 milliseconds for. That's a pretty good speed up, man. I'm not gonna lie. That's about like 30 to 40x. It's pretty good. So a UDF example is another thing. Is you can have something like def multi-label, and I can have something like this. I can have a label, and I can say like sorry, I can have let's just copy what I have. I have multi label. So just so you guys know, I always practice one time before I do a video, most of the times. So like basically, I have a UDF where it gives you if your label is under 1%, it's -2. If it's below 0, it's -1. If it's equal 0 exactly, it's 0. Greater than 0.1 is 2. Otherwise, it's just between 0 and 0.1. I'll do 0.01. And so this is a multi-label. And here you're going to see a huge speed up. So if I do df label and then I do df dot apply, apply. I don't know why it's doing this. Let's do df dot label. What did I call it? Label percent change. That label percent change dot apply. And then I can do get multi. And then I can do time it. I can do this time it thing. And then I can do the same thing but with pandas. And look at the speed difference. This is where this is where you really have a big difference. So look at this. Oops, get multi is here. Get multi label. This one you'll see the bigger difference when you compile after you compile it. So this is 7 milliseconds times that. 7.25 milliseconds. Oh, no wonder it's not a big difference because the compilation is averaged because you're running time it. It's averaged over 7 runs. So that's why it's not that big of a deal. So 4.8 seconds versus the Pandas version, which is a lot longer. I almost think I should. Well, you guys get the point that it's much longer. So in the meantime, let me write. Wow, this is 4 seconds, so it's 1,000 times longer. We really felt that 4 seconds. So group by example. Let's do time. Let's just do time. You get the point. So let's group by label, and let's just do mean of everything else, right? And I did time, not time it, so it runs at just one time. And then, so you see 79.6 is the wall time. You run the second time and it's faster because of the compilation. And now if we run the Pandas version, you'll see, so you see you get 1 second, which is a 20 times difference, which is pretty big difference. Join, or as Pandas calls it, merge example. So let me just create a data set. I'll call it let's say I'll call it lookup, right? And then I'll do lookup is pd.dataframe. I'll do label is 1, 2, and then label name is strong cell hold by strong by. Something like this. I don't know. It's all dummy stuff. I want this to be CudF, so I'll do CudF.dataframe. See, the syntax is pretty much the same, by the way. So I have this lookup, and then let's do a lookup pandas. Lookup.toPandas, and now let's compare the speed, right? So let's do time df.merge lookup on label. Let's do inner, and let's see the speed. Let's run this twice, and then let's run the other one. See, this is 58 milliseconds, 37.6. But now let's do the Pandas version and see how much longer it takes. This is where you're going to really see a speed up here. And of course, this depends on your GPU and CPU and stuff like that. But I just took the worst GPU and it's still a huge speed up. So as you see, the wall time, let's say, is 1 point something seconds compared to this. It's a pretty big improvement. That's like 30, 40 times, if my math is correct. Anyways, I think we're pretty much done. There are some known issues you might want to look into if you look at this link. Some things like there's some known issues. I think I might have clicked the wrong thing, but there's things like mutability. Like in Pandas, you can set things to previous data frame values, that sort of thing. Here, you have to be careful. So always use like mutable things, because CudF copies stuff. And there's other things. There's some issues with like C things and that sort of thing. So be careful with some of these limitations. One more thing I actually wanted to try was, let's see if the RSI thing works. It's not intended for this. Import from Pandas TA. I wonder if it works out of the box. Import, import RSI. And I'll do RSI, DF. I have a feeling it's not going to work. But let's see. Oh, no. What? Huh? That's weird. It didn't return anything. So it must not work, because it returned nothing. So it must not work. So yeah, there's some things that still don't work out of the box. So RSI, for example, we need some work to make it on the GPUs. Anyways, hope you guys enjoyed this video. If you enjoyed this video, please like, subscribe, and most importantly, share. Thank you so much. Have a great day.